So the problem I had the most difficulty with was definitely question 4, parts B and C. So I have them here done out for you the proper way. Part B is asking to solve for the final position. So we have the initial position, 0, 0, 0, initial velocity, final velocity, because the plate stops. So the final velocity will be 0. The initial momentum, the final momentum, again, because the plate is stopped. And this is the calculation for V average, which will come into play later. But first, we're going to use the momentum principle to solve for delta t, because the answer can't be in terms of delta t, because that's not one of the variables given. So, we want P final minus P initial to get F net delta t. P final, again, is 0, 0, 0, so you just get negative of the P initial is equal to negative force, which we set as a variable, times delta t. Solve for delta t, you get m times the velocity over f. You take the magnitude here because you don't want to find the time in vector form. Okay. Now, because we're using the analytic method, the average velocity is equal to Vf plus Vi over 2. So when solving for final position, you want the initial plus V average delta t. So we found V average up here. So you just bring that down, multiply by the delta t value we find here. Again, our initial is 0. So it is just the average velocity times delta t, giving you this is the final value of our f. Now for part C. They're asking you to find the final velocity and final position using the iterative method with 2 time steps. So you start out with your initial values. The value given in the problem is tricky, but this is actually the final force that you're using down here. I messed up the first time thinking this was the initial force, but the initial is actually 0, 0, 0. Same with velocity, same with position. So, for your first time step, the initial force, 0. To find the value of velocity at your first time step, you take the initial velocity plus force divided by mass times delta t, which is the velocity. So, Vx plus, again, force is 0, so that's all just 0. So the velocity at time step 1 is just Vx 0, 0. The position at time step 1 is the initial position plus velocity delta t. Again, this is velocity of step 1 because you were using the iterative method, so V average is equivalent to the final velocity, or the velocity in the last time step. So 0, 0, 0 plus Vx times the time, t over 2, because we're at the first time step, gives us this r value. Now we're ready to move on to the second step using these values to plug in. So the force at the second step, that's where this value comes in, times the time step. This value of velocity at the time step 2 is the value of velocity at time step 1 plus the force here, delta t over m. Vx, again, coming from up here, times this value, which is the force times delta t, t over 2 over m. So you multiply by t over 2 again, which comes down here, and remember this is added, so you don't multiply this Vx, and there's this negative sign here, so it's subtracted. This delta t value only distributes to here. Alright, so this value that you just calculated here is your final velocity. No more work is needed to be done to find velocity. Now all we need to do is find final position. So, position at time step 2 is position at time step 1 plus the velocity of time step 2, which we just found, delta t. remember the position at time step 1 is up here, plus this velocity that we just found, times delta t. I did that all in one step. So the final position will be this value.